Find the equation of a line that passes through points A and B. So if you look on the graph below, you can see I've got 2 points and they have coordinates that are listed. Um, in fact, I'll write those coordinates down. Point A is located at 2, 2, x is 2, and y is 2. B is located at the point 5, 3. X is the number 5, and y is the number 3. So those are ordered pairs for those 2 points. We're asked to find the equation of a line that passes through those 2 points. Well, one of the things we need to know is the slope of that line. We can see the slope in 2 different ways. From this diagram, we can clearly see that we have a rise, right? The rise here is 1. We can also see that we have a run, and the run is 3 units. So looking at this slope triangle, right, we see we have a positive 1 for the rise and a positive 3 for the run. I can see that also by looking at the um, the change in x over the change in y over the change in x. So I'll remind us that the slope of a line m is equal to how much did y change. So sometimes we write down this as a way of remembering that we were looking at the difference between our y's and then over how much x changed. And we can write this down as a reminder that we're looking at how much x values changed. It's kind of arbitrary, but I'm just going to say this is x from my first point. This is y from the first point. This is x from my second point. This is y from the second point. So I can go ahead and say, hey, my slope is going to equal 3 minus 2, 3 minus 2. And in my denominator, the change in my x's, I'm going to take x from the second point, which is 5, and then minus the number 2. So when I evaluate that, 3 minus 2 is the number 1, and 5 minus 2 is 3. And this was such a nice problem, right? We could see the slope already. Sometimes, the slope is not going to be as easy to see as this, or maybe we won't be provided with a graph. But the slope of the line we're trying to find is 1/3. Now, we need to find our y-intercept. And as it turns out, that's not as easy as it looks in this problem because it's not going to be a matter of just counting backwards. It's going to be some fraction. So let's go ahead and find our y-intercept. The technique we've looked at most of this semester is we begin with a nice form of the slope-intercept form of an equation, y equals mx, and then plus b. And we pick one of our 2 points, and it really doesn't matter which one we pick. I'm going to pick this second point. And from this second point, I'm going to plug in the x value, the y value, and we're going to plug in the slope that we found over here, the 1/3, all into this same equation. So y from that point that I've selected was the number 3, right? Y was the number 3. So I'm going to write 3 in for y. My slope was the number 1/3, and my x value from my given point was 5. So what am I looking at? And then write plus b. So we're saying that 3 is equal to 5/3 plus b. And again, if fractions aren't your thing, they should be. They're cool. But I can grab this calculator. And I just need to subtract 5/3 from both sides. So I've got the number 3, and I'm going to subtract 5/3. And when I take 3 and subtract 5/3, I get 4/3. So 4/3 is my y-intercept. So the equation of this line, right, is y is equal to 1/3 x, that's my rise run pattern, plus my y-intercept of 4/3. Very nice. And 4/3 is 3/3 plus one more third. So it's literally going through about here, right? 1/3 of the way past the number 1. All right, the next question says, find the equation of a line that goes through point A and is perpendicular to line AB. Okay, different thing now. Well, and yet a similar thing. I'm going to clear this out. You can rewind it if you need to look at that. This time we already know what the slope of the line that we have is. This slope was 1/3, right? But we now need to find a different equation. And this equation is going to have 2 properties. It's going to be perpendicular to this line that we just found, meaning that it's going to form a right angle to this line. It has to be 90 degrees to that. And if we're trying to find the equation line that's 90 degrees to that, what we looked at when we rotated the plane was what happens if I rotate this plane 90 degrees. This rise and this run switch places. So if I was to take this thing and do a 90-degree rotation around point A, this is what becomes it was the rise, but it's going to become the run. And this piece right here, this 3, is going to just stretch up this way. So now, right, the slope that I'm going to be looking at is going to be, instead of up 1 over 3, I'm going to be looking at a slope of -3. And we like to summarize it like this. This is the slope of the line that I was given. It's up 1 over 3. The slope of the line that's going to be perpendicular, the perpendicular line slope, is going to be -3 over 1, or just simply -3. So what I'm asked to find is the equation of a line that's perpendicular to the red line. In other words, it makes a right angle to the red line, and it passes through point A. It says that it passes through point A. Well, passing through point A is great because we know what point A is, and I know what the slope has to be now. So this one might be even easier than the last one, because if I have to have a slope of -3, right, I can go up 3 and backwards 1. That's a -3 slope. And I could extend that one more jump, going up 1 and then backwards 3. So what I have is, I think I just landed exactly on my y-intercept as well. So I believe that this is the equation of the line that I'm finding. It passes through this point 0.8, and it hits this line, it hits point A also. So the equation of this line, we don't need to solve for B because we can see it landed perfectly there, is y is equal to -3 times x plus the number 8. So starting at 8, going down 3 over 1, and then down 3 over 1.